Hi guys, in this video we're going to have a look at tree diagrams, but this time with dependent events. So in the previous video I did, it was independent, where the events had no impact on each other. However, when it's a dependent event, whatever the first one is, it does have an impact on the second event. Okay, so we need to take that into consideration when we draw our tree diagrams. So I deliberately chose this example here, which is the same one I used for independent events, but in this case with the coloured cubes, and when he picks one at random, he does not replace it. Okay, so this is why when he picks the cube the first time and he does not replace it, obviously when he does it a second time it will have an impact. Okay, so this is an example of a dependent event. But we can still draw a tree diagram and we can still work out the probabilities of him picking a red, one red and one black, and then at least one red. So let's get started. So it starts off exactly the same, where I have two possibilities for the first event. So obviously he could pick a red or he could pick a black. So red, black. And then we still write the probabilities on the branches. So if 4 are red out of 10, to pick a red, he's got a 4 out of 10 chance. And then 6 are black out of 10, so 6 out of 10. And just as before, when you look at the branches, if you add up the branches, the probability will be 10 over 10, which obviously is 1. So remember, the branches need to add up to 1. If they don't, you've made a mistake. So that's the first pick or first event when he does it for the first time. Now he does it for a second time. So again, he's still going to have two options. He's still going to have the choice of red and black. And same down here. Still going to have two choices of red and black. However, this is where it's slightly different. If in the first event or first pick he picks a red, what's the probability he then gets a red again? Well, if we started off with 4 reds and he's picked one and not replaced it, he then has 3 reds that are left. And if there were 10 cubes and he picked one and didn't replace it, there are then 9 cubes left in total. So the probability that he can get red a second time is 3/9. And again, if he had 6 black cubes and he picked a red one, so he still has 6 black, obviously he's then going to have the opportunity or probability of getting 6, and again out of a total of 9. And as you can see on the branches, again 3/9 add 6/9, add them together, 9 over 9, you still get 1. Okay, so it's just taking it step by step and thinking what is the probability. So let's do this one down here then. So if in the first event he picks a black, how many reds does he have? Well, at the start he had 4 reds, and then he's picked a black, so he still has 4 reds. So it'd be 4, and again the total, if he had 10 at the start and he's picked one and not replaced it, he then has 9 in total left. And then the last one here, if he's picked a black, so if there was 6 at the start and he's picked a black, he then has 5 left. And again out of the total of 9, and again those branches there add up to 9 over 9, which is obviously 1. So again, that's a quick check that you can do. Then it's just the same to work out the 4 probabilities at the end of the tree diagram. So red is 4/10. Remember, we multiply along the branches, so 4/10 times 3/9. 4 times 4 is 12, 10 times 9 90. So remember, when you're multiplying fractions, times the top, times the bottom. Red then black. So 4/10 times 6/9. 4 times 6, 24. 10 times 9, 90. And then black red. So 6/10 times 4/9. 6 4s 24. 10 9s 90. And last but not least, black, where we've got 6/10 times 5/9, so 6 5s are 30, and again 10 9s are 90. So there's all the different possibilities, and again, just as before, if you add up all the possible outcomes, so red, black, red, black, these are all the possible outcomes, they should all add up to 1. If you add these up, you get 90 over 90, which is obviously simplified to 1. Okay, so there's our tree diagram. Now let's use that to work out these probabilities. So what's the probability of getting red, red? So just follow the branches. Red, red, 12 over 90. What about next one then? One red and one black. Okay, so let's have a look. So I can't do that one because that's red, red, but I can do this one, red, black. So I've got one red and one black. So red, black, that would be 24 over 90. But I could also go black, red, because again, one of them's red, one of them's black. So I could go that route as well, which again would be 24 over 90. Because these two both satisfy what I want, I just add the probabilities together. So 24 over 90 plus 24 over 90, because the denominators are the same, I'm going to have 48 over 90. That is the other reason why I don't simplify these answers, because if I do need to add them, I've already got the denominator the same. Okay, so that one would have been 48 over 90. And this one here, at least one of them is red. So again, go across the branches, red, red. Well, yep, one of them is at least red, so I can include that one. Red, black, well, again, at least one of them is red, so 24 over 90. Black, red, again, at least one of them is, so again, another 24 over 90. And then black, black, obviously one of them isn't red, so I don't include that one. So if I add these all up, 12, 24, and 24, I should have 60 over 90. The other way you could do it is if you know that these three are what you want, and you know that the one that isn't is 30 over 90, you could just do 90 over 90, take away 30 over 90, which of course will get you the same. So different ways you can do it. I like doing it this way because then I can check my roots and make sure that I have got it. Okay, so that was one example linked very closely with the example I did in the independent events, just to show you the different. I've just got one more example to show you, so bear with me a second. So here we go, here's another example, just slightly different. Rob has a box of 20 chocolates, 14 are milk chocolate and the rest are dark chocolate. Rob picks one at random and eats it, so obviously therefore it's not replaced, and then he picks a second and eats it. Okay, so again we can use a tree diagram to do this, and obviously it's going to be a dependent event because if he eats one of them, obviously that will affect the second time he picks it, or picks a chocolate, sorry. So, what are our choices? Well, we can have milk chocolate, or we can have dark chocolate. Okay, so this is the first pick. So there are 14 milk chocolates, so 14 out of 20 is the probability of him picking milk. And it doesn't tell you how many are dark chocolate, it just says the rest are dark. Well, if there's 20 in total and 14 are milk, there must be 6 dark chocolates out of 20. Okay, so there's the first pick. And obviously the second one is still going to have the same choices. He can still get a milk chocolate or a dark chocolate, and exactly the same down here. So that's what I'm going to do. Just write that down, and then I'm going to work out the probabilities. Again, this is where you need to be quite careful. So if he's picked a milk chocolate first and eaten it, and there were 14 at the start, but he eats one, there's going to be 13 milk chocolates left. And obviously if there were 20 chocolates in total and he eats one, there are going to be 19 left. And there was 6 dark at the start. He eats a milk, so there's still going to be 6 dark. But again, the total will be 19 because he's eaten one. And again, these will add up to 19 over 19, which obviously simplifies to 1. Next one, if he picks or eats a dark chocolate, how many milk does he have? Well, he started off with 14. He's eaten a dark, so there's still going to be 14 milk left. And obviously the total will be 19. And then if he's got 6 dark and eats one, there'll be 5 left, and again the total will be 19. Again, these branches here will add up to be 1. So there is our tree diagram. So if I want to work out all the probabilities for these 4 then, I'm going to have 14 over 20 times 13 over 19, and that gives me 182 over 380. Then I'm going to do 14 over 20 times by 6 over 19, and that'll give me 84 over 380. Again, notice I'm not simplifying these because the denominators will remain the same, so it's handy. Dark and milk, So that would be 6 over 20 times 14 over 19, which is 84 again over 380. And then dark, so 6 over 20 times 5 over 19, and then that will be 30 over 380. Okay, so now I've got all the probabilities I could possibly need to answer any question. So let's go through it then. The probability of milk, well, that's 182 over 380. Nice and easy. The probability of one of each. So I've got two choices here, milk dark and dark milk. So I'm going to have 84 over 380 plus the 84 over 380. So if I add them together, that'd be 168 over 380. And finally one here, at least one of them dark. So milk, nope, they're both milk, but I can have milk dark, which is 84 over 380, plus dark and then milk. So at least one of them is dark, that's cool. So 84 over 380. And then obviously dark, obviously at least one of them is. So 30 over 380, and if I add them all up, I think I get 198 over 380. So yeah, just two examples there, guys, of tree diagrams when they are dependent events. So the second event is dependent on what happens in the first event. So hopefully that helps explain that. Thanks for watching. Cheers.